Good morning, everyone. Good morning.
Good morning.
Good morning. So today we'll start the new module. The same again. It is a continuation of gears itself. The same thing would be repeated once again in the form of bevel and worm gear. So first we will start with worm. We shall finish worm gear. We'll learn how to design a worm gear, and then we will go with bevel. Bevel is nothing but it is simple. It would be a perpendicular shaft. I'm talking about the bevel. So one gear would be something like this. Okay. And another gear would be attached perpendicular like this. Something like this. So perpendicular shaft. So for the perpendicular shafts, we'll be using bevel gas. So that bevel gas will cover after the worm gas. So worm gas you can see here. So this is an worm gear. Why is this gear so important for us? We already had spur gear. We already had the helical gear, even the bevel gear also. What is the requirement of this particular worm gear? Just by looking at the figure, are you able to understand how this gear system works? Can you know the animation? Can you feel the animation? Can you? So there would be a worm. Worm in the sense why it is called as worm andre ಏನು ಕನ್ನಡದಲ್ಲಿ it is a ಹುಳ. ಹುಳ ಅಂತೀವಲ್ಲ. Millipede, centipede, it is nothing but something like that. So this particular thing, whatever is there, is known as a worm. Okay, this worm will be rotating. While it is rotating, it feels like some worm is moving around. If you have an imagination, you'll come to know. So when you rotate a screw in front of your eye, you feel something, a worm is moving. That is how the name has been came for this. It is known as worm. So this particular shaft is known as a worm. And whatever it is driving, this particular worm is driving this huge wheel. This is known as a worm wheel. What is the significance of this worm gear or a worm wheel or a worm? Why it is so important for us in the sense, suppose, think there is a gear, okay, there is a pinion and there is a gear. So you are rotating this gear at about 100 rpm. So you can reduce to this particular speed, or you can increase to how much? Say around 300 rpm max to max. So from 300 rpm to 100 rpm, if you want to reduce, your size would be approximately something this much, isn't it? Suppose same thing, if I want to reduce your 500 rpm to just say 50 rpm. Now I want to reduce what? I want to reduce 500 rpm to 50 rpm. Then think the pinion would be small and the gear will be large again, just to compensate the velocity ratio. Are you getting the imagination? Okay. So is this practically possible to do such a gear system where pinion is very, very, very small and your gear well is very, very, very big? Is it practically feasible to accommodate such things in the industry? It looks absurd, isn't it? So in order to reduce this problem, if I want to have a high velocity ratio, then I would go with a worm wheel. Suppose this worm is, if it rotates say 10 rpm, so 10 revolutions if it turn, what happens? Only a bit of this worm would be moved. Only this much would be moved. Suppose if it want the whole thing, that means if it want a complete revolution of this worm, it should rotate around how much? 50 rpm. Around, I'm just saying it randomly to make you understand why this worm and worm wheel concepts is being introduced. So you should turn 50 times this particular wheel so that it completes one revolution. Think of your reduction in velocity ratio. So you can achieve the velocity ratio up to 300, 400, 500 velocity ratio. So that is why if you want a such huge velocity ratio, you can directly go with the worm wheel. It is preferable that you go with the worm wheel rather than you go with the spur or a helical or a bevel. Is that clear? Why the worm and the worm wheel concept is being used? Clear with this concepts of worm wheel? Any doubts?
Yes, sir. Yes. No, sir.
Yes.
So any doubts if you have how this particular thing operates and kind of, anyhow, we'll be going in depth about the design in the coming times, but mechanism of it, concepts of it, anything you want to discuss, you can discuss, otherwise we'll move on. Yes? Anything is there? Any doubts? One thing is eventually there, man. See, if you are rubbing this, see, if you are rubbing this continuously, so think of this particular portion. I'll use that different color. Think of this particular portion which is engaging. So this particular portion which I have highlighted here would be a tremendous rubbing action all throughout the process. Is it not? So if there is a more rubbing action, automatically the heat generated would be more in a worm gap. So that should be taken care of. The additional parameter which is should be taken care of is the heat generated. So since your rubbing is more, automatically the heat would be generated would be more. So that you have to taken care of. That one disadvantage is there with the worm wheel. Okay. Okay. We will directly move with the problem. So all these theoretical concepts you'll come to know while solving the problems itself. So you have a design procedure neatly written, and even it was there for this thing also. Which one? For the spur and helical gears also. I think that I have not even touched this design procedure part and directly moved into the problem. Was there any difficulty over there? Because wasting time here, you will never come to know. To find the diameter, use this equation. All those procedures would be given there. No issue. I can explain this, but it is of no use, I guess, because you will remember nothing out of it once I explain also, right? So rather, I would prefer to directly go with the problem. Then if you come back and read your design procedure, as in case of bevel and spur, you will feel lot more confident. If I just explain it now, it will be like a bulk for you. Hope you understand why I'm doing this, right? Now directly go with the problem. We'll solve a problem. All of you take this problem. I'll give you a couple of minutes. A triple threaded, I will just explain it. Just take the problem. So a triple threaded worm has a teeth of 6 mm. So he has given, just a minute. So there are two categories of problems in a worm wheel. Listen this carefully. One category is where the center distance is given. Okay, what is first category of the problem? So before I start somewhere, I have to write this. So there are two category of the problems, two types of problems I can say. Okay, you write it in your notes. Okay, first type is where center distance is given. If center distance is given, you have to follow a certain procedure. So that is A is given. And second type where your center distance is not given. Is not given. Or center distance is given, is known, or it's not known. Based on that, you have to choose a little bit modifications you have to do in your problem. Okay. So we shall see one by one. So this first particular problem is just for to make you understand certain parameters. That's it. Okay, it is not a design-oriented problem. This particular problem is not a design-oriented problem. Rather, it is just a basic problem. It would never be asked in the examination. Keep this in mind. It is just to understand the parameters. Just it. Okay. Now, a triple-threaded worm has a teeth of 6 mm. He says 6 mm module. Teeth of 6 mm module. So I would just write. So module is how much? 6 mm, which is directly given in this. Teeth is being given how much? Triple threaded in the sense. See, in the worm will be having either 1 thread, 2 thread, 3 thread, or 4 thread. That's it. Will not go major than that. What is this thread as? How many of the screws is being engaged? Suppose 3 screws are engaged, then it is a 3-threaded worm. If 2 screws are engaged or 2 that convolutions are engaged, then it is a 2-threaded worm. It is like that. Okay. Now, so that's why it is triple-threaded worm. So Z1, I will be taking it as 3 there. Next, has a circle diameter, pitch circle diameter of 50 mm. So D1 is 50 mm. So D1 is how much? 50 mm I would take. Next, if the worm has 30 teeth, worm in the sense it is worm wheel he is talking about. So it has how much? It has 30 teeth. Okay, that is being given. And 14 and a half and the coefficient 13 and 30 teeth, 14 and a half in the sense that is the pressure angle which is being mentioned alpha, 14 and a half degrees that I will be taking. Coefficient of friction of worm gearing is 0.05 and this is a new parameter, so that you can take it as mu. Okay, coefficient of friction is given by mu, denoted by mu, and it is given as how much? It is given as 0.05. Find whatever you have to find here. First thing, you have to find the efficiency of the worm. So how do you find the efficiency? You have a certain equations in your data handbook. All of you open your data handbook. Just look into the worm gear, whatever the data I can take from the data handbook to solve this problem, even that can be done. Okay, just have a look of the data handbook in the worm gear segment. So first there will be a spur gear segment. Next there will be a helical gear segment. Next there will be a bevel gear segment. After that, worm gear segment would start. So in the worm gear segment, you'll be having a multiple formulas there. You can pick whichever you require for the problems, wherever. Okay. First thing you have to find the efficiency. Second thing, he has asked to calculate the lead angle. So lead angle is denoted by gamma like this. So that is known as lead angle that you have to find out. And third, you have to find out the velocity ratio, which is I dash. So in the worm concept, you'll not use I, but you'll be using I dash here because it is not actually the velocity ratio. Since both the systems are not gears, one is a screw thread and other is a gear, you'll be using I dash over there. Fourth one, you have to find the center distance, which is A. So center distance is nothing but the distance between the centers. So this is your center distance that you have to find it. Okay, shall we go up with the solution? Yes. Yes or no? Shall we go up with the solution? Okay. Now, all of you open your data handbook and look in the worm gear segment. I need an expression to calculate my lead angle with the available content. I need an expression to calculate my lead angle from your data handbook. Please, can you look into your data handbook and give me a suggestion how I can calculate my lead angle? Because for calculating the efficiency, I require the lead angle. So that I am calculating my lead angle first. So look for the expression where I can calculate my lead angle, which is gamma.
So page 221,
Page 221, equation number
12.28.
12.28. What does it say? Page 221. Na?
Yes, sir.
Okay, we just cross 221. Yes.
12.4.
12.46.
46.
So I can use this thing. I would take that. I would take that particular thing. Tan of gamma is equals to L divided by pi d1. That is equals to same thing I have taken. Whatever is being mentioned there, I have taken. What is L? L in the sense it is this one, which I am taking here. Now, what is L? L is pi m z1. So just take that. Okay. Next is pi d1. So pi get cancels. It is m z1 divided by d1. So do I have the value of module given? I have the value of module given. So how much is the value left? Module still 6 mm cross z1. Z1 is still 3, correct? 3 over there. D1 50. This everything is equal to tan of gamma. Now I want tan inverse of this particular thing in terms of degrees. How much is the value? Okay, 19.79 degrees. Everyone getting the same value? Tan inverse of, make sure it is in degrees, not in radians. Okay, got 19.71. Next, immediately you can find the velocity ratio. So I dash is given by n1 by n2, same thing again, d2 by d1 divided by z2 by z1. So you have 30 number of teeth in the worm wheel and 3 in your worm. So the I dash should be how much? 10. So 3 ones are 330. Next, go for center distance. Center distance is given by d1 plus d2 divided by 2, right? So that was the center distance formula. And d2 is nothing but m times of z2, that you know that. D is m into z. Okay. So here it is, d2 is equal to m z2 into m2. Same thing I have taken, m into z2. Now substitute the values here. d1 is 50 plus m is how much? M is 6 mm into z2 is 30 divided by 2. Now, what is the center distance? Center distance 115 mm, 115 mm. Good. Very good. So 115 mm. So now you can go with the efficiency. Now, but just go with this particular formula: efficiency of the worm gearing. Efficiency of worm gearing, eta. Do you have any formula? Just check your data handbook and let me know. Something that would be written in bar's formula. So the formula through which you can calculate your efficiency is given by bar's, B-A-R-R. B-A-R-R, bar's formula. Okay. Just check it. Do you have any sort of expression to calculate the value of efficiency of worm gearing? 12.57. What is the page number? The kada 5, okay, 57, no? 5, 6, 5, 6, 5, 6. Efficiency. So you have so theta is angle of deflection. You don't have it, so forget about it. You see, you can pick this particular formula, no? Right? 12.570. Efficiency is equals to tan gamma. Gamma is the thing with your lead angle. 1 minus mu. Mu is the coefficient of friction, which is given in the problem. So all of the parameters you know, so that you can pick this formula. Just take that particular formula there, which is known as the Barr's formula, which is given by equation number 12.570 in page number 225, and substitute all the parameters. So tan gamma, so tan of 19.79 into 1 minus mu is 0.05 cross tan of again 19.79, close the bracket, 0.05 mu plus tan of 19.79. So this whole thing, if you multiply it by 100, you'll get the value and the percentage. So what is the value? %. Correct value. 86%. Okay. Everyone got the same value? Okay. Next, I told you there are two types of design-oriented problems in case of a worm design. The first one is where the center distance is known, and the second one is where the center distance is unknown. So we will take up a problem where the center distance is known, which is this. Okay, just write the problem in your notes and write the given data. If you can analyze it, it would be very good. Just write the given data, we'll start the problem after a couple of minutes. Okay, shall we start the problem? Okay. Design a suitable worm gearing. So clearly indicates he wants a worm gearing to be designed with the following details. So he requires the power transmission of 3.75 kilowatt. Speed ratio, that is I dash. I told you virtual speed ratio I dash is 27 what is required. And pressure angle he is required as 14.5 degrees, the pressure angle. Center distance is being given, that is the main killer feature what we are looking for. So since center distance is given, the procedure would vary. So here in this particular example, he has given the center distance 180 mm. Worm speed in the sense the speed of the worm, which is you can draw a small thing like this. Okay, there will be a worm, so drawing rectangle, a worm, and there will be a worm wheel. So this is 1 and this is 2. So this is what? This is worm and this is worm wheel. Okay, so N1 he has given us how much? 1200 RPM. Okay, so capital N would be in RPM, as I discussed in the last classes also. Capital N is nothing but RPM, and small n is nothing but your RPS. So if I want to convert this into RPS, what should I do? What should I do if I want to convert RPM into RPS? Yes? What should I do to convert RPM into RPS? No one knows
Divide by
about, right?
60.
Okay, divide by 60. So divide by 60, if you do 1200 divided by 60, 6 get cancelled, 6 ones are 6 twos are. So it is 20 RPS. Okay. Next. Next, what else is given? Let us just write. The material for the worm is hardened steel. The material for the worm is what? It is hardened steel. I would just write it here. Hardened steel. And with the design stress, so sigma D1 is how much? 45 megapascal. So this is material of the worm. And that of worm wheel is phosphorus bronze. So always remember the desirable material in case of a worm wheel is phosphorus bronze. Why? Because the worm wheel will be subjected to high amount of wear and tear as compared to worm. Worm will be just rotating in its axis, but the worm wheel will be a sliding, it would be a rubbing on the worm wheel. Okay, ಒಳ್ಳೆ ತಿಕ್ದಂಗೆ ಆಗ್ತಾ ಇರುತ್ತೆ ವರ್ಮ್ ವೀಲ್ ಮೇಲೆ. ಈ ಗ್ರೈಂಡಿಂಗ್ ಮಷೀನ್ ಇಂದ ನಾವು ಫೈಲಿಂಗ್ ಮಾಡ್ದಂಗೆ ಆಗ್ತಾ ಇರುತ್ತೆ. ಸೊ ಈ ಸರ್ಫೇಸ್ ಎಲ್ಲ ಹಾಳಾಗ್ತಾ ಇರುತ್ತೆ. ಸೊ ದಟ್ಸ್ ವೈ ವರ್ಮ್ ವೀಲ್ ಇಸ್ ಮೇಡ್ ಇನ್ ಹಾರ್ಡ್ ಅಂಡ್ so phosphorus bronze use ಮಾಡ್ತೇವೆ ನಾವು usually. So since in the question also he has given phosphorus bronze, that is well and good. So phosphorus bronze ಅದರದ್ದೇನನ್ನು ಕೊಟ್ಟಿದ್ದಾನೆ? Design stress sigma D2 is 52 megapascal. So 52 megapascal. So this is the different data which is being mentioned in the question. Shall we go up with the solution? So I just told you just now that out of worm and worm wheel, which will be subjected to more stress? Which will be subjected to more rubbing action? Yes?
Wheel.
Wheel, isn't it? In case of this, so just write the sentence like this. Okay. Just write the sentence. Identifying the weaker part is our first step, isn't it? So just write the sentence. The worm gear is assumed to be weaker than the worm. The worm gear is assumed to be weaker than the worm since it is subjected to sliding action resulting in overheating and leading to failures. So always when you observe a worm and a worm wheel, no, we usually think common average engineering knowledge ಇರುವಂತ ಒಬ್ಬ ಯಾವುದೇ ವ್ಯಕ್ತಿ, any kind of a guy, if you just look into worm and a worm wheel, what does he think? Worm would be most affected rather than the worm wheel. Yes or no? ನಿಮಗೆ ಎಷ್ಟು ಜನಕ್ಕೆ ಆ ಥರ ಅನಿಸಿದೆ? Just raise your hands. Worm will be most affected rather than the worm wheel. How many of you felt so? Right? Correct? So, but it is not the case. What happens, worm wheel will be subjected to more stress as compared to the worm. So that's why we will be designing the entire gear system, treating worm wheel as your weaker part. So first step is to find the diameters. Okay. To find the diameter, you have an expression in the page number 12. So don't directly take from the screen. Please go to your data handbook. Check for the expression 12.51a from the page 223. From there, you pick the expression d is equals to a to the power of 0.875 divided by 1.466. Pick that particular expression from there. So we are using this. Why? Because since the center distance is known. Okay. Now, a value he has given as 180. Just substitute 180 over there and give me the value of T1. look into your data handbook. So you have to look. Don't directly take the expression from the screen, because when you look 2 to 3 times, when you take the expression, then the data handbook will be used to you. Next time, whenever you solve the things, you will directly come to know in the examination. Okay, that is why you have to look into the data handbook and then take. 64.1, can I take it as 65 mm? So better to take it as, approximately I would take it as 65 mm. Next, pitch diameter of the worm we have found out now, which is 1. Next, pitch diameter of the worm wheel or a worm gear. So you have there, right? A is given. So A is 180. So D1 is 65. D2 has to be found out. Give me the value of D2. So the right way to deal with design classes is have a laptop with you in front of. In that, put the screen on a full screen mode. In front of your table, take your data handbook, take your book, take your calculator, and start working on, hearing to the instructions what I say. Okay, so 295 mm. 295 mm. Okay. Next, you go with the finding the module. To find the module, you have this expression. Take it. It is given by equation number 12.53a. Suppose if in case you do not find this expression, or there is a mistake in an expression which I have written, I have taken it from the textbook, so I am saying you. So if it is there is a mistake in the expression number or page number or in the expression itself, please kindly let me know. And I insist everyone to use your data handbook to look into the expressions where exactly they are located in your data handbook. That is very, very important. Okay. Okay. Equation number 12.53a in page number 223, it says Ft is equals to sigma d CV b capital Y and M. So from this, you will be calculating M there. So calculate, in order to calculate CV, you require V. For V, you have pi D2 N2. N2 is in CPS. If you want capital N2, you can use it. It is pi D2 divided by 6. So either of the expressions you can use. It's up to you, whichever you use. Same old fashion you can use. Since the textbook has used this particular expression, I'm using it. Same thing. You'll get the same values, no issue. Pi into 0.295 in meters, I'm substituting it 0.741. What is the value? You have to substitute N2, not N1. That too in RPS. If you want to substitute in RPN, divide by 60. That's it. Velocity 0. Very good. So velocity would be very, very low, guys, in case of the worm wheel, because your worm wheel, you can literally see how it is rotating. Okay, in case of a spur and helical gear, ಒಂಥರ ಬ್ಲರ್ ಆಗ್ಬಿಡುತ್ತೆ ಫಾಸ್ಟ್ ಆಗಿ ರೊಟೇಟ್ ಆದಾಗ. You can literally slow ಆಗಿ ಮೂವ್ ಆಗ್ತಾ ಇರುತ್ತೆ worm wheel. So literally you can see the velocity of wheel. ಎಷ್ಟು ಬಂದಿದೆ velocity 0.6867. 6867. So for this particular thing, pick up the expression from 12.53 A, B, C, whatever is required based on velocity in the page number 223. Okay. Just give me the value of CV. Same, ಅದೇ ಮತ್ತೆ ಸ್ಪರ್ ಗೇರ್ ಹೆಲಿಕಲ್ ಗೇರ್ ಅಲ್ಲಿ ಏನ್ ಮಾಡಿದ್ರಲ್ಲ ಅದೇ ಇರುತ್ತೆ, little bit modification ಇರುತ್ತೆ ಅಷ್ಟೇ. Same again, the same thing, same procedure. CV value ಕೊಡಿ. Fancy number, 0.8989. Now next, go with the calculation of phase width since it is required here. Phase width is given by equation number 12.64 in the page number 227. I tell you, please look into the data handbook and have a habit of taking that particular expression, looking into a data handbook, not by looking at the screen. I have just written here for your reference. That's it. Pick the expression from your data handbook. Take your time. No hurry. If you can stop me, you have to stop me in between. It's very important that you look into a data handbook and take the expression from there. Okay? Don't be in a hurry. 47.02. So approximately I can make it to 48. If I do further approximation, I can make it to 50. Okay. Next, go with the calculation of FT. So same old formula, but here there is a hinge there. You require to take, you just read this equation 12.53D, which is in page number 223. If I just rotate this screen, 53D. See here. So this is the permissible tooth load or tangential load, which is given by this particular expression. Here it says it is not just MT, but it is MTE. But in the further where he has given clearly, MTE is nothing but MT into KL. That is effective torque. KL is what? Load stress factor. You can pick it from the table 12.33. Now all of you go to the table number 12.33 and give me the value of KL. $12.33. What is the table? ಏನೇನಿದೆ ಆ ಟೇಬಲ್ ಅಲ್ಲಿ ನೋಡಿ 12.33 ಅಲ್ಲಿ 12.33 ಓ ಹಾಗೆ ಹೋಯ್ತಾ 12.33 So this is the value of KL that you can assume, okay, that you can take. So ಇಲ್ಲಿ ಏನಿದೆ ಡ್ರೈವರ್ ಯಾವುದು ಡ್ರಿವನ್ ಯಾವುದು ಅಂತ ಮೆಷಿನರಿ ಕೊಡಬೇಕು. Okay, whether it is driving by the electric motor connect ಮಾಡಿದ್ಯಾ ಪಂಪಿಗೆ ಅಥವಾ ಸ್ಟೀಮ್ ಟರ್ಬೈನ್ ಕನೆಕ್ಟ್ ಮಾಡಿದ್ಯಾ ಅಥವಾ you are driving, suppose if you come for a driven member, ರಬ್ಬರ್ ಮಿಲ್ ರೊಟೇಟ್ ಮಾಡ್ತಿದ್ಯಾ, ಕಂಪ್ರೆಸರ್ ರೊಟೇಟ್ ಮಾಡ್ತಿದ್ಯಾ, ಪಂಪ್ ರೊಟೇಟ್ ಮಾಡ್ತಿದ್ಯಾ, ವಾಟ್ ಆರ್ ಡ್ರೈವಿಂಗ್, ಇಫ್ ಎನಿ ಆಫ್ ದೋಸ್ ಇನ್ಫಾರ್ಮೇಶನ್ಸ್ ಆರ್ ಗಿವನ್, you can choose these factors. Any other information, any information is given regarding what is driver and what is driven in the problem, ಏನಾದರೂ ಕೊಟ್ಟಿದ್ದಾರಾ ಪ್ರಾಬ್ಲಮ್ ಅಲ್ಲಿ? ಏನ್ ಪಂಪ್ ರೊಟೇಟ್ ಮಾಡ್ತಿದೇನೋ ಅಥವಾ ಫ್ಯಾನ್ ರೊಟೇಟ್ ಮಾಡ್ತಾ ಇದ್ದಾನೋ? Anything given in the problem? Nothing is given in the problem, isn't it? That's why when nothing is given in the problem, what you have to do is write it in red color. Okay, if nothing is specified, then take the value of KL to be 1. So you can write assuming the value of KL as 1 there, since nothing is specified. If it is specified, then you have to be take that particular value there. Okay. In order to calculate this, I think you don't have the value of MT, right? So for that, you can use this 2 pi NT by 60. If N is in RPM, then it is N by 60. If it is not RPM, then it is just small n into MT. Okay, just substitute the parameters over there and calculate the torque. How much is the torque? What is the value of the torque given? Okay. What is that value? 806 torque. Okay. 806. 806. 806.52. So just substitute the value of MT here. Just substitute the value of MT here and calculate your FT, tangential load. So what is the formula value of?
Sir, the equation ಎಲ್ಲಿಂದ ಬಂತು?
ಯಾವುದಪ್ಪ?
P equals to 2 pi n to mt.
ಅಯ್ಯೋ ಅದು ಎಂಥದ್ದು ಇಲ್ಲ ಕಣೋ. ಇದ್ರಲ್ಲಿ ಏನ್ ಗೊತ್ತಾ ಅದು? P is equals to 2 pi nt by 60. ಇದಂತ ಗೊತ್ತಾ ನಿಂಗೆ ಎಕ್ಸ್ಪ್ರೆಷನ್? ವೆರಿ ಫೆಮಿಲಿಯರ್ ಫೇಮಸ್ ಎಕ್ಸ್ಪ್ರೆಷನ್ ತಾನೆ? ಓಕೆ, ಇದರಲ್ಲಿ ನೋಡಿ 2 pi n by 60 is small n, right?
Okay.
ಅಲ್ಲಿ ಬರ್ದಿರ್ತಾನೆ ಬೇಕಾದ್ರೆ ರೆಫರೆನ್ಸಿಗೆ. FT value ಅಲ್ಲಿ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಿ. 806.52 is your value of torque. 1 is your value of KL, which is assumed. Give me the value of FT.
Sir, DT should be in mm only.
ಏನಪ್ಪ?
D to mm only.
It should be in mm only. Just if you have a doubt, no, you come back here and check that. In the previous table, while we are calculating it, it should be in mm itself. Okay. mm ಏನದು? ಸ್ಪೆಸಿಫೈ ಮಾಡಿದಾನ T2 ಯಾವುದ್ರಲ್ಲಿ ಇರಬೇಕು ಅಂತ ಸ್ಪೆಸಿಫೈ ಮಾಡಲಿಲ್ಲ. 5.4 ಎಲ್ರಿಗೂ 5.4 ಬರ್ತಾ ಇದೆನಾ? ಓಕೆ, ದೆನ್ ಯು ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಇಟ್ ಇನ್ meters. You substitute this in meters. If you substitute in meters, what is the value? 5450 na? 5460 na? 5425. So 5425.2 newtons. Okay. Now it is matching. So in textbook answer is 5460. In and around it is matching. Okay. 5425.2. Next, you have to go with capital Y. So if you get capital Y, you can calculate your value. So how to do it? So Levy's form factor, directly you can go with the table 12.28C from page number 244. 244 page number. Okay. In this, see, this is very, very important, guys. Okay. So you have to refer 2 to 3 tables. These 3 tables are there, no cunning tables there. Now, from this, see what are the different values you can get. Just have a glance there. Values of Y for the worm gear you can get. And suppose I told you, single thread, if it is the velocity ratio is 20 and over, it would be a single thread in case of a worm, in the worm there. If the velocity ratio is between these two, then it is a double thread in the worm. All this data you can get. And the correlation between the lead angle and the pressure angle. So even that data you can get it from here. So as of now, what we require is we require the form factor value, that is capital Y. For 14 and a half, this thing, 14 and a half pressure angle. So the form factor, you can directly get it as 0.1 from the table number 12.cc, 12.28c in page number, what was the page number I have mentioned? 244. Okay. So from this Lewis form factor, I can choose it to be 0.1 directly based on the pressure angle. So capital Y is nothing but pi times of small y. So small y, we have just taken it as 0.1. So it is pi times of 0.1. Now you have all the values. So what you do is, Z1. Okay, illi Z nimage kottillalla. So what you have to do, Z1 is not being given there. So number of teeth kottillalla. You require that also. So you can, again, I told you, come to this particular thing, check for the velocity ratio. So you have multiple velocity ratio ranges there. In that particular range, what is the requirement of the number of threads? You have to note it down. Okay, for example, here, what is the velocity ratio? How much is the velocity ratio? What is the velocity ratio in this particular problem? 27. So for 27, that means it is 20 and over, isn't it? For 20 and over, number of threads in the worm is how much? He has said it as single, no? So that's why you have to take Z1 to be as just 1 there. Suppose if it comes, if your velocity ratio is in and around 10, if the velocity ratio is, I'm just giving the example, if in and around 10, then it comes in the range of 10 to 12, isn't it? So in this, what is the recommended number of threads in the worm? It is triple. That means you have to take the Z1 value as 3, right? So as in case of this thing, 27 is the velocity ratio. So it comes 20 and over. So it is single. That is why I'm taking Z1 as 1. Okay, so the same thing I have written here. So for I dash greater than 20, Z1 is equal to 1. I'll just put it in the box. Z1 is equal to 1. From where you have selected this? From the table number 12.28P, which is in the page number 244. Now immediately you can calculate the value of Z2, which is I times of the value of Z1. So 1 cross 27 is again 27 teeth in case of a worm V. Substituting all the parameters. If the velocity ratio is 12, which one? Better to take a smaller value always in case of this. If it is, suppose if I take 10 also, which I previously, which was discussing, so it comes in the range of 8 to 12, as well as it comes in the range of 6 to 12, as well as it comes in the range of 4 to 10. X or no? So always the preferable values are the values at the top. So you should not go sextuple, quadruple. Those are all nonsense, and it is very difficult to manufacture also. So always go with the shorter ones. Okay. Single, if not double. Double is not possible, then go for triple. If triple is not possible, then go for quadruple. I think quadruple is the last, will not go for sextuple. I have not seen a gear which is a sextuple. Very rare case. Even in my industrial experience also, I have never seen a gear which is sextuple. Okay. Sextuple in the sense 6 threads should be matching with the worm. Very difficult to manufacture. Huge gears it would be. 27. Clear with this doubt, Mithun? Okay. Now, 27. So just substitute all the values there in the equation number 12.53a. Substitute all the values and give me the value of module. Okay, 7.8. So just go with the standardizing this using the same table number 12.2, page number 229. Give me the standard module. So I think 8 mm would be the standard module as per the textbook. Just check whether it is 8 or not. Okay. So we have fixed upon the module as 8 mm. We will have a necessary check since we have assumed a lot of things in the problem. We will have a necessary check whether the selected module 8 is worthy, whether it is satisfactory or not, and how to check it. We will discuss in the next class. Okay. So
Sir,
you can mark your attendance in the attendance sheet, Google Sheet, and leave the class. Okay.
sir.
Vikit, ಹೇಳು.
ವೈ ಕ್ಯಾಪಿಟಲ್ ವೈ ತಗೊಳ್ಳಿಕ್ಕಲ್ಲ ಸರ್.
ಹೌದು.
ಕ್ಯಾಪಿಟಲ್ ವೈ 0.341 ಬರ್ತದಲ್ಲ, 314.
ಹೌದು.
ನೀವು ಇಲ್ಲಿ 0.1 ತಗೊಂಡಿದ್ದೀರಾ?
ಇಲ್ಲಪ್ಪ, ಡೈರೆಕ್ಟ್ ಆಗಿ ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್
ಓಕೆ 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 ಫೈನ್.
ಸರ್
ಗೌಸ್ ಹೇಳು.
ಅದು 8 ವ್ಯಾಲ್ಯೂ ಅದು ಹೇಗೆ ಸರ್ ಬಂದದ್ದು?
ಯಾವ 8? ಎಲ್ಲಿದೆ ಅದು?
ಅದು
ಯಾವ್ದು ಹೇಳು ಗೌಸ್?
ವಿ ಫೈಂಡ್ ಔಟ್ ಮಾಡಬಹುದು ಸರ್.
ಪವರ್ ಇದೆ ಸರ್.
ಈ 8
I equals 20 by 1.
ವಿ ಇಸ್ ಈಕ್ವಲ್
ನಿನ್ನ ಹತ್ರ ಐ ಉಂಟಲ್ಲ, ಉಂಟಲ್ಲ. ಓಕೆ
ಸರ್, ಅಟೆಂಡೆನ್ಸ್ ಶೀಟ್ ಅಲ್ಲಿ ಪ್ರೀವಿಯಸ್ ಡಿಲೀಟ್ ಮಾಡಿದ್ರು.
ಹೌದು, ಮಾಡಿ ಬಾ. ಒಂದೇ ನಿಮಿಷ ಗೌಸ್, ನಾನು ಹೇಳ್ತೇನೆ. ಒಂದೇ ನಿಮಿಷ ಹೇಳ್ತಾನೆ.
ಸರ್ ಆದ್ವಿಕ್ ಆಗಿ ಪ್ರೆಸೆಂಟ್ ಮಾಡಿ.
ಮಾಡ್ತಾನೆ. ಎಲ್ಲಿದೆ
ಸರ್
ಒಂದೇ ನಿಮಿಷ ತಾಳಿ. ಒಂದೇ ನಿಮಿಷ.
ಸರ್ ಹರ್ಷ ಕೂಡ ಸರ್.